Howdy do, kiddos. Let's solve some multi-step equations. Today, our essential question is how can I use distributive property and combining like terms to help solve complicated multi-step equations? Here's the deal. We're going to start doing some very complicated equations today, but we have some tools at our disposal, and we'll refer back to these tools many times throughout the period or throughout the video. We're going to be making use of the distributive property to free the x's from parentheses. We're also going to make use of combining like terms to combine the x's, get things together. And of course, all of this is on our way to getting x on a side by itself. We also have this guy in all of his weirdness to help us along. So let's look at example number 1, and notice this is the most complicated equation we've seen so far this year. If you're still kind of relying on doing equations in your head, you may want to stop at this point and try my nice little vertical method of doing things. It's a good way to organize yourself. You should be getting used to copying each step every time because this is complicated. And the reason it's complicated is because look, I have two terms that are x's over here. I have a term that doesn't involve an x over here, and then on the other side of the equal sign I have something, and I need a nice way still to get x equals a number as my final step. So let's think about the tools that we can use. First of all, I can combine like terms. So before even thinking about canceling or doing the inverses, let's just combine 8x minus 3x is 5x minus 10 equals 20. So look, I'm writing my steps each time I combined my x's. Now I have just one term with an x because I combined the two terms. And at this point, the equation is easier, right? I have a minus 10, so I can add 10 to both sides to cancel the minus 10 from the side with the x. That leaves me with 5x on that side, and on the other side I have 20 plus 10, which is 30. Then I can cancel the 5 from in front of the x by dividing. So x equals 30 divided by 5 is 6. I really want to make a plug for doing the equations vertically like this because it keeps your work best organized. None of this nonsense like putting equals 6 over here. Don't do that. Keep your work nice and vertically organized. Get used to it. Let's just check our answer real quick because I made a mistake in the last video and I don't want to do that again. I'm plugging 6 in everywhere I see an x. So here, 8 times 6, 48. Here, 3 times x, 24. Here I have a minus 10. So let's just make sure, okay, 48 minus 24 is 24. And 24 minus 10 is 14. So it looks like I've done something wrong because 14 does not equal 20. So, here's what I did wrong. This is a simple fix. I did 3 times 6 is 24, but it's not, you foolish teacher, you. It's 18. 48 minus 18 is 20. Sorry, 30. 30 minus 10 is 20. Blah. Okay, so I messed up in the checking the work because I was trying to go too fast. But this definitely equals 20. So I got the right x. Wasn't that fun? Checking the work with Mr. Gregory. Woohoo! Example 2. All right. Complicated. Why? Because on this left-hand side of the equation, not only do I have x in two different places, but I also have parentheses. So I need to make use of the tool at my disposal that frees the x from the parentheses. A lot of you might be tempted to do something like this. You might be tempted to add 5 to both sides to cancel it here. But it doesn't. I'm not allowed to cancel 5 out of parentheses. It's trapped in the parentheses. Like jail. Parentheses are like jail. 5 is trapped in there. Likewise, as with the last problem, you might be tempted to combine the 6x and the x to 7x. But you can't because the x is also trapped in parentheses. Whenever I have parentheses, I need to make use of the distributive property. So let's do that first. That will kill the parentheses for us and untrap the x and the 5. So I'm distributing negative 2 to the x and the minus 5. And again, I'm recopying the whole rest of the equation. Recopy the 6x. I haven't used it. Then next, negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. And on the other side of the equation, I have 46. And I rewrote everything to keep myself organized. At this point, I have x's in two different places. Luckily, they combine. 6x minus 2x is 4x. And then rewrite everything else. At this point, I have a nice two-step problem left. I can simply subtract 10. That cancels it from this side and leaves me with 4x equals 36. And I can divide through by 4 to cancel that 4, which leaves me with x equals 9. Let's see if I can not embarrass myself by checking the work here quickly. If I plug 9 in everywhere I see an x, 6 times 9 is 54. Also in the parentheses, I would have 9 minus 5, which is 4. And negative 2 times 4 is negative 8. 54 minus 8, yes, is 46. Very nice. Follow the order of operations there. I went kind of quickly through it. Finally, example 3. This is our last example for the day. Notice that I have parentheses again, so I'm not allowed to do something like this. Not allowed because the 5 is trapped inside the parentheses. I shouldn't do something like this. This is bad for multiple reasons, but the main one I want to highlight is that it's trapped inside the parentheses. We could use the distributive property, but if I use the distributive property here, 3 over 2 times 3 would be 9 over 2x. And then also multiplying 3 over 2 times 5 is going to be giving me a similarly ugly fraction. But let's think about this. Let's think about using reverse PEMDAS. We know with PEMDAS the parentheses come first, but since I'm undoing an equation, I could think of the parentheses coming last. And before that is the multiplication. So I have 3 over 2 times what's in the parentheses. If I can undo this multiplication, that would be another way of freeing 3x plus 5 from the parentheses. So how do I undo multiplication when I have a fraction? Well, I multiply by the reciprocal, 2 over 3. I'm going to multiply 2 over 3 to both sides. Keep in mind that when I multiply 2 over 3 to both sides, pre-reducing here cancels it to 1. And what am I left with? Well, I'm left with just 3x plus 5 on this side. Or I don't even need the parentheses because there's nothing multiplying them anymore. So just 3x plus 5. Nice. So sometimes if the only thing that's happening is multiplication times two terms in parentheses, you can simply multiply by the reciprocal to cancel that term that's multiplying the parentheses. Let's take care of the other side. I have a fraction multiplication problem. And looks like the negative 24 and the 3 pre-reduced to negative 8 over 1. So all I have is negative 8 times 2, which is negative 16. So again, the big trick that I did there, if I have just one set of parentheses with the fraction multiplying them, go ahead and multiply by the reciprocal. That will cancel it before you even have to distribute. Now the problem is easy. Let's subtract 5 to cancel. On the right, I have negative 21. On the left, I'm just left with 3x. And I'll divide through by 3 to give me that x equals negative 7. And just a reminder, I'm going to keep plugging this for the whole rest of the year. Show your steps. Look how organized it is. It's very easy. It's very easy for me to go back and catch mistakes. All right, that's all the examples I have for you today. Just in summary, do make use of the distributive property and combining like terms to get you to the point where you have x equals a number as your final step. And don't forget, in equation 3, we kind of talked about how we didn't even need to use the distributive property. Sometimes you can pre-cancel by multiplying by the reciprocal. Thanks for watching.